son of a gun. Let's try that again. All right, we're going over the homework. We already did questions 1, 2, and 3 in class yesterday. So that's 3, 2, and 1. And starting with question 4, the answer is 1, 5, 1, 6, 1. 7, something about as you go right along the stream velocity axis. So as you go right, the speed is speeding up. So since the speed's speeding up, then you'll have more erosion. So more erosion because it's moving faster and picking up more / bigger sediments. Then flipping that onto the back, we have question 8. The answer is 3, 9, 3, 10, 1, 11, 4. Yeah. 10. All right, 10. Yeah, you too. Hopefully I did it right. As water velocity of a stream increases from 5 to 30 centimeters per second, in which order will particles of different sizes begin to move? So when we were starting at 5 centimeters per second, that's right here. So 5, sorry, I gotta make a nice straight line. 2, 3, 4. So right there, the sediments that will begin to move, it looks like, so did you pick, which one did you pick? Okay, so the key is that at 5, silt was already moving. Okay, so as you go from 5 to 30, silt's way down here. So silt was moving more like at 0.5 centimeters per second. So at 5, silt starts to move, then the pebbles, and the cobbles. And did we go all the way to boulders? Yes, because it goes to 300. So just, that's a reading question. I don't think the ones on the regions will be that, or tomorrow's test is that difficult. Good question. So I don't remember. 11 is 4, 12 is 3, and 13 is 1. Are there any others I should go over? 12 is 3. Got it? Which one wrong? Want me to go over it? Which one, Brennan? 12. So 12 says, as compaction and sedimentation of these sediments eventually occurs, which one will become siltstone? So that's a throwback to chapter 3 too, 3 as well. So there's silt. Siltstone is made out of silt, which is anything from 0.0004 to 0.006. So in this reading right here, and it did tell you in the reading, it says the accompanying profile shows the average diameter of sediments sorted and deposited in these areas. So in area C, from here to here, it's sediments that are 0.0004 to 0.006. So that's silt. So then when that silt gets compacted together, it's going to become siltstone. Make sense? Okay. Again, I think that's a little complicated than what'll be on the test tomorrow. So I think you are good. Anybody else want me to go over any more specific questions? Then in that case, I think we are officially done with chapter 5. I was going over the test a little while ago, and there was one phrase that I think we left off of our review sheets. You guys still have your review sheets handy? There was one phrase that or technically 2 phrases that mean the opposite of each other, that I wanted to make sure that we got. Did we have an extra bubble on yours, or should I find a different spot to write this? If you have an extra bubble, write it there. If not, there's some room in the top margins and the bottom margins. The 2 phrases. Transported sediments versus residual sediments. That shows up a couple times on the test tomorrow. What does it mean to be a transported sediment? Sediments were moved. Sediments have been moved. Residual sediments? Mm-hmm. Yeah, I know I talked about it in the one video, so I'd assume then you probably went further. What is residual soil? Did I spell it right, first of all? I think so. It's like residue. And I think this is how I compared it in the video. I'm not sure. This is how I do it every year anyway. Residue, the perfect example of residue is after you eat a bowl of Kraft macaroni and cheese. Even after you have moved all the sediments sediments meaning macaroni and cheese, into your belly, there's still macaroni and cheese residue in the bowl. And what does that mean by residue in the bowl? Left over. Can't move it into your belly, and I guess unless you lick it off. And we don't have to talk about who does it and who doesn't, because that would be embarrassing. But anyway, residual means not moved. Had stuck there. Didn't get moved from one place to another. So as Mr. D was saying, so it might be helpful to remember on the test tomorrow that you have a map. And on this map, talks about places like the Catskills and the Adirondacks and the Allegheny Plateau. So that sediments can move from one place down to another place, depending on different agents of erosion. So keep in mind, tomorrow you are welcome to use a map if you need one. Hint, hint, wink, wink. Mr. D, do you know I'm not going to be here tomorrow? I told you that, right? Okay. Guys, I'm not going to be here tomorrow. So there'll be a sub here organizing you taking the test. I haven't decided if we're putting the answers on Teams or not. I'll be deciding that in the next hour or so. Check the board for, like, the board will have a bunch of notes on it tomorrow because I will be here in the morning. So I'll make sure everything is set for you guys. Good? Then that's it for chapter 5. Thank freaking goodness. Longest chapter ever. Definitely is long to begin with, but then me being out, we've repeated some things a couple times, gone over a couple things, skipped a couple things, forgot to teach them, taught them yesterday. I'm thinking you're going to really like chapter 6 a lot better. Did everybody pick up the packet? Chapter 6 is Earth history. So you know how much you just had to memorize for chapter 5? There's a lot of memorizing in there, right? Glaciers, moraines, and all those just key words. Well, this chapter, there is 0 things to memorize this chapter. Absolutely nothing that you have to memorize because everything you need for this chapter pretty much is on pages 8 and 9 of your reference table. So if you could open your reference table to 8 and 9. Anthony, if you didn't already grab a packet, grab it. Eight and 9, so I actually just skipped ahead a little bit. We're going to come back to 8 and 9. So just have that set aside. But the good news is that I want to tell you, first of all, the Regents loves this chapter. They have like 5, 6 or so questions on this chapter alone, which doesn't sound like a lot, but when there's only 85 questions and 5, 6, or 7 of them are on this chapter, that's up in near 10% of the questions. Not quite 10, it's a little less, but it's a lot more questions. Take a look at 8 and 9 of the reference table. What do you see on there? Look through it a little bit. First, fossils. First of all, is there a lot of stuff on that page or a little bit of stuff on that page? There's a freaking lot of stuff on these 2 pages. There's so much that the Regents out of 16 pages devoted 2 pages to nothing but this chapter. So that means it's important. One thing I want to show, does that look really easy to read? No. And that's what we're going to basically be spending the whole week learning, how to read this messy chart. But the good news is not one single thing do you have to memorize because it's on here. 8 and 9. So also I want to point out, this is why I stapled them like this in a book, because this book, these 2 pages go together. So I just got out of order a little bit. The first thing I want to do now that you have these reference tables is give you extra credit. Who still has their original blue reference table? Let's see them all. Hold them up. Hold them up. We've got 1, 4, Nate, Jesse, Riley, Gabby, Tyler, Michael, Brendan, Renee, Sean, Calvin, Jake. Oh, Anthony, that stinks to be you.
Mine's white.
Trent, I gave you a blue one.
That's a bit racist, no?
Riley, yeah, not that last time I checked. You got yours, Danny? Yuppers, I see it. Carlos. Shelby. Listen. And all right, you guys have earned 1 extra point on your average. Meaning, if you had a 64, I just upped your grade to a 65. If you had an 89, I just upped you to a 90. If you had 99, I just upped you to 100. Sorry, your grade stays where it was. I told you this at the beginning of the year. Yep, told you you got to keep your original blue reference table. Told you that was part of it. You had to treat it like it was an extra point every single quarter. I will admit, I forgot to give you a point last year or last quarter. Nah, because that's not quite fair to poor little Anthony there. Got your packets? We are going to go to page 3 of your packet. So, oh, okay. So we're not doing too much today. So like Jake and Riley were a little nervous. I was going to teach you new stuff. Or was that Jake and Shelby? It was Riley. Okay. Jake and Riley were a little concerned that we're going to do new stuff before the test. It's okay. Not going to be overloading your brain. There will be no confusion. I promise. But I do want to get an introduction, and that's because you're going to be starting this in lab tomorrow. We're not going to be doing too much of the actual earth science part of it tomorrow, but we're going to be getting you started on this lab starting tomorrow and then again on Monday. So I didn't want you to be completely left behind on the lab and not have a clue what was going on. You'll still be a little struggling. If you have Mr. Miga, ask for help because he knows that I wasn't there yet. His students are done and over with it. My students were not there yet. So ask for help if you're confused. Anyway, we're going to be talking about history, just like in history class. The only difference is instead of talking about like the last 100 years or 200 years or 2,000 years, we're talking about the history of the entire Earth from the day the Earth was born until today. So it's a big difference. I want to also say, I know some people have different beliefs than other people with this, but you can believe what you want at home and you can still believe it here, but you need to be able to answer the questions that are on the reference table. So you can still believe what you want, but if you want to get a passing grade on the test and the Regents, you have to read the information straight off the reference table. If you don't believe it, don't believe it. Treat it like any other thing you learn in school. You have to answer what I teach you, okay? Whether you like it or not. Moving, and sorry, we won't have time to debate, even though it could be cool and fun. We can't. Anyway, we're starting off with relative time and absolute time. These are 2 phrases the Regents love. Any idea what either one of them means? We think absolute time is. The exact time. Oh, I should also say, can you take where it says absolute time, put slash date or slash age as well? Oh, page 3. I'm sorry, you're right, page 3. So absolute time, date, or age. All 3 of them pretty much mean the same thing. Same with relative time slash age slash date. They all, I might just interchange them. So absolute time, just like Shelby said. Here, and I'm sorry if you can't see these because I wrote them in red, let me know. It says, so just write in your bubble, just like this, gives a date or time of an event, such as April 5th, 1983. That's an exact time. It's a very important absolute date as well. Remember how I said you didn't have to memorize anything? That's one thing you should probably memorize this year is April 5th. Okay. Anthony, you don't want to question me on this? No? Okay. All right. Okay, thanks. April 5th. It is the most important day you have to remember this year. It is my birthday. I like chocolates, coffee, candles. I prefer vanilla cupcakes over chocolate cupcakes. You don't have to bring enough to share, just enough for me. Okay, just saying. Anyway, April 5th, 1983, the day I was born. That's an absolute time. I am not that old. Okay. I will be 39. Yes, 39. Right? Yeah, 39. I am currently 30. Math gets hard when you get those big numbers. So if that's absolute time, give an exact date. What's a relative time though? Kind of, but not really. So he said an estimate or about, and how many of you were probably thinking that as well? An absolute is an exact relative. No, you're just the only one willing to talk because I guarantee that's what they were all thinking. They just aren't, or they weren't thinking at all. It's not quite right though. No, what do you think?
Is it like a time period?
Not really, but not. No, you want to give it a whirl?
Relative time. So like, I was born after World War II.
Perfect. I was going to use a different example, but you're right. That's perfect. My go-to question is, how old am I relative to you? How do you answer that question?
We were born after you.
That's one way. No, so you don't even have to think that hard. So Anthony said you were born after me. Perfect. Or you could say, because I could said, how old am I relative to you? Older. End of story. How tall am I relative to? Sorry, Jesse. Jesse, how tall am I relative to Jesse? Oh, Carter too. Shorter. Okay, you don't really need to know how tall I am. You don't need to know how tall Carter and Jesse are. You just know that they're taller than me. Okay, so taller. So you don't need to know the details. You just need to know. So it's still kind of an about. So you weren't wrong. But what it does is it puts dates or events in a sequence. I was born, then you were born. Oh, sorry, that's the next bubble. There's 2 bubbles there. So then let me quiz you. No, let me take a drink first. What about me saying I was born in April 1983? Is that an absolute time or a relative time then? Think about it. Look at the definitions. It's still an absolute. It still gives you a time frame of when I was born. It didn't say I was born before you. That's relative. How about saying I was born in 1983? Is that absolute or relative? Still an absolute. Yes, it's a bigger time frame, but it still is an exact time frame. You can pin down when I was born. How about me saying I was born in the 80s? Still absolute. So I know it's, so that's where it gets a little weird with the whole about or exact. So it still is an exact time frame. You can still pin down when-ish I was born. It doesn't put me in order or like you're younger, I'm older. It's still an absolute time on a calendar. We'll come back and forth with this. Now, I see I already pushed this button. I didn't mean to, but whatever. To date really old things, like to figure out how old they are, we're going to use this thing called radioactive dating. Some of you like dinosaur buffs or people like that might not have heard of carbon dating. Anybody? Yeah, okay. So a few of you have heard of this. Most people have not. So this will be the first time we talk about it. We're going to spend a whole week talking about radioactive dating. To figure out the relative age of things, we're going to use this thing called the law of superposition. Again, we'll spend a whole week talking about the law of superposition. But before we talk about any of that, we're going to be talking about some events that have happened in Earth's history. And that's where we're going to be using pages 8 and 9 of your reference table. If you look on that same page, so on page 3, you'll see a textbook reading about how to use pages 8 and 9. You can read that if you don't remember some of the things we talk about over the next couple of days. So if you ever forget how to do pages 8 and 9 of your reference table, there's notes on it. We're gonna more just kind of do some things hands-on here. But before we get started thinking too much, make sure you understand some simple concepts. Everybody got this? You guys have been in social studies for a very long time now. What's one way, so what's one way that, what am I trying to get at here? You've used timelines before, right? You guys don't need too much instruction on how to read a timeline. Give me, let's if we were to draw your timeline for you, what would I typically start with? When you were born. So you start a timeline, they typically look like this, right?
Are we going year by year?
We could. So we could go year by year.
So you turn 1.
Okay.
And then there's not much that happens. Then you turn 2. And then you turn 3 and your parents get divorced.
Okay. So what other things might be on a timeline?
First word.
Okay, so you might talk about first talk, first words, whatever. Oh, do you want to talk about getting them or losing them? Okay, sometimes we talk about when you get your first tooth. Might also add when you lose your first tooth. You guys get how to read a timeline, right? What if it was a timeline of a war? Okay, so you might have war started. On the timeline? Ended. Okay. Yeah, so you might have like important events in that war. So if it was World War II, right, so you might put at the very beginning. Okay. Woo! So then you might have different battles. Now, ooh, so you guys got this, at least those two do. What's one thing about your social studies test, when you are taking a social studies test, what's one thing that is hard to do on a social studies test? In fact, I think Anthony already demonstrated it to me. Somewhere on there is the Battle of Britain, or whatever he said.
That's not exact timing at all. I think that's called a stupid inevitable.
No, not at all. No, he demonstrated this. So my question was, what's difficult about a test in social studies?
You don't know the exact
You-
time. It's
okay.
relative.
No, dude, I'm not even talking about earth science. My point is memorizing dates. Anthony knew that there was a Battle of Britain. He knew it was important. He couldn't remember the exact date. Because social studies makes you memorize all this stuff. Good news is this year in earth science, it's all in your packet.
It was
We're-
1940.
GTK, bro. Good to know.
When was the Battle of Stalingrad?
We are moving on. This 8 and 9 is a timeline. Take a look at page 8. So since we're doing a timeline of the Earth, it's not going to start with when you were born. When does it start? When does it start? The timeline of the Earth. When the Earth was birthed. When the Earth was born. Take a look and see if you can find what says how is it worded? It says estimated time origin or something like that of Earth and the solar system. Look through this reference table. See if you can find where it says estimated origin of Earth.
Are we gonna cover dinosaurs this year?
No, Earth science, not life science. You found it? Okay, so guys, I asked you a question and only a few people are doing it. I asked you to find when the Earth was birthed. Where did you find it? What's its general location for everybody who's looking? It's right here. So I know you guys can't see mine super good. That's why I had you get it out in front of you. Everybody point to where it says Earth's time of origin. Bottom leftish corner.
4,600 million years.
Yep, 4,600 million years ago. So there's where the Earth was born. Now, can you find today on this map or reference table?
No, this wasn't made today.
No, it is. Can you find today on this timeline?
Oh, it's up at the top right-ish.
How do you know? Does it say today?
Humans, mastodons, mammoths.
No, can you find today on here?
What's that?
Okay, how about this, guys? Find today on there. If the Earth was born 4,600 million years ago, when's today? You find it, Riley? What is it? 0 million years ago is today.
I was really close.
So right there, guys, stop. 0 million years ago at the top is today. So this timeline, instead of going born and then increasing until you get to today when you guys are 15 or 16 going across, this one does it backward. Well, it doesn't do it backwards, it just does it differently. Has at the bottom, you're born, and at the top, today. So this timeline is broken up a little different. But it's still just a timeline with important details in between. So I see a few of you labeling this. That sounds like a really good idea. I would put up here where it says 0 million years ago, I would label that today. So as you guys established, I was born pretty long ago, back in the 80s. What are some of the ways that we would talk about the time frames from when I was born? In other words, how do we break up time now? Normal time. What are some of the ways we do minutes, seconds, and hours? What are some other ways we break up time? Months, days, years, decades, centuries, don't forget centuries, and millennials, or millenniums, is really, sorry. So we break up time, you guys know the concept of that. What's the smallest unit of time you guys just mentioned? Well, I don't know if anybody said that, but yeah, seconds. And then what was the biggest time frame we were talking about there? Would be most amount of years. That's a big one, but we kept going. Decades is 10 years. We talked about millennials. Yeah. Centuries 100, that's pretty big, but we did talk about a millennial. Either way. Well, they break up time on the timelines in a very similar way. But instead, because we're talking about more than a million years, more than 1,000 years, they get broken up into these eons, eras, periods, and epochs. So the biggest unit of time is an eon. An eon gets broken up into an era. What do you think eras get broken up into? Periods. Periods get broken up into epochs. And then you may notice then there's some more millions of years here. This is as far as we're going to get for today. We're going to get into more details on this on Monday, and you're going to start this on Monday and Tuesday in lab. All right, so that's it. Remember, you have a test tomorrow.